Okay, for number 11, we've got two parallelograms and they're similar. So the dimensions of the larger parallelogram is 8.4 times the dimensions of the smaller one. Okay, so for me in this one here, I'm going to go ahead, and you kind of been working this one out already. I'm actually going to use a rectangle. And in my rectangle, this is 1 and this is 2. So my area is 2. And my perimeter is 1, and the 2 over here, add up the sides, is 6. Now 8.4 times. So I'm going to go just the smallest times I can go here. And play with those numbers. And it's not drawn to scale, by the way, guys. So 8.4 would be this one, which means this side is 8.4. This side would be 16 point something. Let's see what that's going to give me. 16.8, I think. Why 16.8? Will double the size. And so yes, I'm going to use my calculator a little bit for that. Just so that you guys know. Now I'm going to get me the new area. So the new area is 8.4 times 16.8. And you're going to see me work this out. Let me see if I can get to my calculator. Okay, so my original dimensions are 1 and 2. So that area is 2. Then 8.4. I'll eventually be able to use this. Hopefully it'll let me work. 0.4 times 2, by the way, that's my 16.8. That's the dimension. That's why I get the double of the size here. So 8.4 times 16.8. So it's 144. This is off, so 16.8. There we go, it's better. Now, to determine the scale factor, I get that 141.12, and I divide it by that 2, and it's at 70.56. So it's 74.6 larger, and I guarantee it's here. There it is. Now the perimeter, the new perimeter, let's take a look at that. I got 6 over here. Here I'm going to add everything up, the 8.4, the 8.4, 16.8, 16.8. Let's add it all up. There we go. Let's see here. So I got 8.4 plus 8.4. Oops, nothing's working today, man. Plus 8.4. 84. I'll get it to work. It'll work eventually. Plus. I just hope it doesn't. It's not like this when you're actually taking the test. That's my concern. 16.8, 40. So that is 40. So 40.4 divided by that 6. That was our other perimeter. So 6.7. Might have been a mistake here somewhere, man. For all I know, right here, the 16 should be a 1. So it's 50.4. There's my 8.4. So the perimeter is 8.4. So the perimeter is going to be 8.4 times larger than the smaller one. And then the area is a difference of 70.56 times, larger than the smaller one. So that's what you do, guys, in this one. It's kind of different. I have a feeling if I go 8.4 squared, I'm going to get the answer. Let's check this out. Let's see here. Let's go 8.4 squared. There's that 70.56. I don't know if your teachers discussed it in 8th grade, but I do it with my Algebra 1 kids during the days of tax, but also in my geometry classes. When you play on dimensions, like if you double the dimensions of the sides of a parallelogram or rectangle, you're just going to square the dimension size. There's areas in square units. That's the only thing. So you get that 8.4, you square it. So we did here 8.4, and you square it, and you get that 70.6. But it only works when you double all the sides. Okay. In the meantime, I just draw it out, write down some numbers, and then plug and chug the math. Very doable. It's a 2-pointer. Easiest way to do this one is to actually just experience it as a lecture, and then you just kind of know what to do every single time.